Hello friends, welcome all of you in this video lecture of quantum theory. This is our first topic for the semester 5th of BSc part 3. So firstly, you all will be safe and you are taking care of your family in this COVID-19 pandemic. So you all will be safe with your family. So we will start our quantum theory topic. So if you look in the screen, the introduction about the classical mechanics, because when we have to understand the quantum theory, then we must know the two mechanics, out of which first one is classical mechanics. So now what is classical mechanics? So classical mechanics is totally depends upon Newton's laws of motion. You have studied this Newton's laws of motion in your ninth or 10th standard. So there are totally three laws of motion. So if you have forget that, you may revise it. And how this classical mechanics is depends on the Newton's laws of motion, we will see in the next part. So the second point is of classical mechanics provides extremely accurate result when we studying the large object that are not extremely massive. That means the objects which are not massive, that means which are too big in its shape. So in this case, Newton's laws of motion doesn't apply. That means classical mechanics does not follow for the extremely massive objects. And the speed of the object should be less than the speed of the light. म्हणजेच लाईटच्या स्पीड पेक्षा त्या ऑब्जेक्टचा जो स्पीड आहे किंवा वेलोसिटी आहे तो कमी असला पाहिजे आणि तो ऑब्जेक्ट मॅसिव्ह नकोय, तरच क्लासिकल मेकॅनिक्स त्याला अप्लाय करता येतं. And the third point regarding classical mechanics is we can predict the motion of an object according to the classical mechanics. म्हणजेच पुढच्या ग्राफमध्ये पाहिल्यानंतर तुमच्या लक्षात येईल की आपण एखाद्या ऑब्जेक्टचा स्पीड, डिस्टन्स त्याच्या विथ रिस्पेक्ट टू स्पीड कसं कॅल्क्युलेट करू शकतो. So that is the best application of classical mechanics. We will see the next slide. So the classical theories deals with macroscopic particles. That means particles which we can see, which we can observe. So that particles are nothing but macroscopic particles. And this classical theory totally depends upon the Maxwell's electromagnetic theory, according to which any amount of energy may be emitted or absorbed continuously. So energy is continuously emitting or absorbing. Out of these two, any one process may be occur in classical mechanics or in electromagnetic theory given by the Maxwell. So the former point which is explained here, it is possible to predict the position and velocity, that is nothing but the momentum of an object. In this graph, if you look here, there is a simple graph plotted between the distance and time. So time present in hours and distance is in kilometers. Suppose one person in 2 hours, it is about 25 kilometer it is crossing the distance. So we can predict after 5 hours how much distance will be crossed or covered by that person. We can predict with the help of this classical mechanics. So in this way, this was the best applications of the classical theory. But after some time, that means up to 1905 पर्यंत क्लासिकल मेकॅनिक्स व्यवस्थित होतं. पण त्याच्यानंतर जसे जसे शोध लागत गेले तसं तसं क्लासिकल मेकॅनिक्स मध्ये प्रॉब्लेम्स क्रिएट व्हायला लागले. So if you see the next slide, you will get idea about that. So now the second mechanics, that is the quantum mechanics. Now why the classical mechanics was necessary to understand the quantum mechanics? Regarding this, we can see here there are two scientists, one was Schrödinger and second one was Heisenberg, which makes a large changes in classical mechanics, and there was a formation of quantum mechanics. Now see this difference. What we study in classical was for macroscopic, but quantum mechanics is for microscopic particles. That means as like electron, proton, neutron. It takes into account the Heisenberg's uncertainty principle and wave particle duality. आता जसं क्लासिकल मेकॅनिक्स मध्ये आपण इलेक्ट्रोमॅग्नेटिक थेरी बघितली, मॅक्सवेलने दिलेली इलेक्ट्रोमॅग्नेटिक थेरी त्याला ऍप्लिकेशन होत होते. तर तसंच नेमकं क्वांटम मेकॅनिक्स कुठल्या दोन कन्सेप्ट वरती बेस्ड आहे. सो दॅट इज नथिंग बट फर्स्ट वन इज हायझेनबर्ग्स अनसर्टनिटी प्रिन्सिपल and second one is wave particle duality, that is nothing but de Broglie's hypothesis, which will be study in the next two slides. So it is based upon the Planck's quantum theory. Classical was based on the Maxwell's electromagnetic theory, but it is totally depends upon the Planck's quantum theory. That means the famous equation which we know that E is equal to h nu given by the scientist Planck's, that also create a large change in classical theory. Then again it gives probability of finding the particle at various location in space. But in classical we studied that we can accurately determine the position or the distance or the time required to cover the distance. It was accurate. But in case of quantum mechanics, no accuracy is there. There is a probability. It means there are chances to find. So we'll see the next slide. Now out of that, first one is dual nature of matter. That means we are going towards the de Broglie's hypothesis. Now what is dual nature of matter? Now till 1905 light was considered to be a wave. जे लाईट जी आहे ती वेव्ह फॉर्म मध्ये असते असं 1905 पर्यंत कन्सिडर केलं जायचं. त्याच बेसिसवरती आपण काही कन्सेप्ट 11वी-12वी मध्ये शिकलेले आहेत. सो दॅट कन्सेप्ट्स आर नथिंग बट इंटरफरन्स, diffraction, polarization. So all these are based on the wave nature of light. But when photoelectric effect proved successfully and world believe that light has a particle nature also. So you also studied the photoelectric effect, I think in 12th or in BSc 1. So photo means light, electric field is there, electricity is there. Now what is this effect? When photons falls on the surface of metal, that time electrons get ejected from that metal surface. So in this way, that is the photoelectric effect. You can revise it. So this effect totally proves that light has also another nature, and that is the particle nature. Photoelectrons are emitting, that is nothing but the particles. So same as like photoelectric effect, Compton effect, black body radiation, both these concepts are based on the particle nature of light. So what we can conclude, light is made up of wave as well as particle nature. In this diagram, tree diagram, you can see here light consists of wave as well as particle nature. So by studying this, the scientist who was doing his PhD and he write in his thesis, de Broglie suggested that if light can behave as a dual character, then why not matter? So he wrote that matter also have a dual character because matter can behave both as a particle as well as wave. जर का लाईट वेव्ह फॉर्म मध्ये असेल आणि तो जर पार्टिकल नेचर दाखवत असेल तर मॅटर जो की पार्टिकल फॉर्म मध्ये आपल्याला आढळतो किंवा दिसतो तर तो वेव्ह का असू शकत नाही, अशा प्रकारचा कन्सेप्ट डी ब्रॉग्लीजने मांडला आणि त्यालाच आपण डी ब्रॉग्लीज हायपोथेसिसच्या नावाने ओळखतो. So for your syllabus there is a derivation given by the de Broglie's. So we will see how he derived the equation, that is de Broglie's hypothesis. In that we have to consider de Broglie's equation. Now if you see, according to the Planck's theory which we have seen in the former slide, so energy of photon of light is given by E is equal to h nu. So this famous equation is known as Planck's equation, where h is the Planck's constant. Its value is 6.626 into 10 raised to minus 34 and nu is the frequency of radiation. So according to this theory, one new theory was used in case of quantum mechanics, and that was given by the famous scientist Einstein, and that is theory of relativity, where energy of photon, that is nothing but the particle, if it has a mass m, Then according to Einstein's equation, E is equal to mc square. So that is mass energy relationship. So by comparing these two equations, we can write left hand side is for energy. So we can compare right hand side. So h nu is equal to mc square. But for nu, that is nothing but frequency. For frequency, we have equation, that is velocity of light c divided by wavelength. That is nu is nothing but c by lambda. Then putting the value of nu, you can write here c by lambda. So equation become hc by lambda is equal to mc square. That is h by lambda. You can write here m into c only. So one c get cancelled. So what remains? H by lambda is equal to m into c. So what is lambda? So lambda is equal to h by mc, where c is velocity of light. So photon travels in a space with velocity c, that is velocity of light. Then its momentum p is given as p is equal to m into c. Hence the equation lambda is equal to h by p. That is also you can write m into v. So lambda is equal to h upon mv. So de Broglie suggested that any particle which have a mass m and if it carries a velocity v always exhibit a wave nature and its wavelength is given by lambda is equal to h upon mv or h by p. So this equation is known as de Broglie's equation. So in the next slide, what he concluded? Conclusion of the de Broglie's hypothesis states that the equation gives relationship between momentum of electron, which we considered as a particle, and wavelength of the electron considered as a wave. So it is a relationship between wavelength and momentum. So wavelength, that is lambda, is a very small or negligible for relatively large object, that is nothing but macro particles, as like a person. So we are massive particles. So for that it is very small. But for subatomic particles like electron, proton, neutron, so wavelength lambda is not small to be neglected. So we cannot neglect in case of electron or proton. We have to consider it. So the same equation is correlated with kinetic energy. So in terms of kinetic energy, if any object having the mass m and velocity v, then kinetic energy is always equal to half into mv square. So momentum is nothing but mass into velocity. So velocity is nothing but momentum upon mass. So put up the value of v into the equation of kinetic energy. You will get half into m. Put up for v, that is p by m square. It becomes p square upon m square. So 1 m get cancelled. So it is simply p square by 2m. So p square is equal to 2m into k, or momentum is equal to square root of 2 into k into m. So on this equation, we have to solve numericals in our next lecture. So thank you.